Warm evening, sir. Hello.
Hello. Yeah.
Sir, I couldn't join previous class. How can I access?
Yeah. Hello. Yeah. Can you please repeat? Hello.
Yeah, sure, sir. Sir, I couldn't join previous class. How can I access?
Previous problem solving sessions or this course content?
Sir, problem solving.
Okay. This is first formal problem solving session from my side. So there will be no problem. We will go through all aspects what we can cover in this meeting. So don't worry about that.
All right, sir. Thank you.
Just some time. Let me admit all the members. Abhishek, just a second. Let me admit everyone. Then I will start. Okay, so I think that's it. Actually, there is some constraint with this meet. At one time, only 100 people can join. So that's why I think, and there are two different sessions from two different TAs. So you can either join both, and if not able to join, then you can join one of them. That will also be helpful to you. Okay, so I think we can start. So, very good evening. I am Saurabh from IIT Patna and PMRF TA for this course, Database Management System, which is taught by Professor Parth Pratim Das and Professor Samiran Chattopadhyay. So, in this problem solving session, every Tuesday we will discuss some of the concepts and some previous year questions in order to make sure that you are able to means solve the problems which is given in this run assignment. So uh, I think we can now get started. Okay. So this problem solving session is based on week one content. Okay. Just Okay, so 100 members are over. Uh, so those who are not able to join, this meeting is getting recorded. So I will upload it after this session. So they can see from there, and they can ask the questions in the comment section. So in this week, the topics covered are basically first, professor told about this levels of abstraction, then schemas and instances, then database design, in that logical and physical design, then data models, then relational models. Based upon this, we will actually go today. So first thing is, what are databases? What is database management system? So in database, so okay, those who are joining, please don't leave. If you will leave, you may not be able to join, as the maximum limit of this meeting is 100 people. Okay, so if you will not, if you will leave, you may not be able to join again. Please. uh, okay. So, what is database management system? So, database uh, databases are actually the collection of interrelated data. It In this basically, if you have data related to like banks, like airlines, like any other existing systems, so you want to store in the data in an efficient way, and you want to manipulate that data. You want to every time use that data efficiently. So again, someone is joining and leaving. Please don't do this. Just join, then just try to join. If you will just leave, you will not be able to join again. Please. Okay. So databases are actually very large in size, and it can be of any aspects of our life. So to okay. So to store these database systems efficiently, and you can say to manipulate. If you want to manipulate, you should you want any kind of language or anything. Hello.
Database management system Python. ఇదేనా నేను
So let's wait for 5 more minutes. Everyone is joining again and again. Let me admit all. Okay. So in database, okay. Before database there was a system called file systems. So with the help of that file system we wanted to store our data or information in forms of files. So there were many problems related to that, like data redundancy, data duplication, data isolation. So okay. So we are starting for this run from today only. So from today onwards, from yesterday onwards, yesterday there was one session and today there is one session. Consider this as week one. Okay. So last some lectures were based upon some previous runs. So those will not be considered fully under this course formally. So from today onwards, formally we are starting this session. Okay. So drawbacks of file systems were that if there were multiple data of same kind, we have to store it in different files, and due to that there will be duplication. There will be many things like isolation and atomicity was needed for this file system. But the problem was these were increasing the storage capacity, storage complexity, as well as the consistency of data. So for that, we uh, we started using this database system where we want to store our data so that a single data, which is may be used for different purposes, should be stored in only one way, and we can access from there, and we can use it for different tasks. So uh, there was a question in discussion forum like concurrent access is very right. So example of concurrent access, you can say like in IRCTC system, whenever you see there are available tickets, basically in mostly you can see in case of the car tickets. So when you start booking these tickets, then there will be some other number. When it ends, there will be some means a smaller number will be there for available seats, or there will be some waiting list. Okay, so what happens that each of the user, there are multiple users, those are using simultaneously the system. So what we want that with each updation, the different user should get updated to the with the current state. Like in PPTs, there was also example like if there is a balance say 100, and at the same time you are checking the balance, at the same time we are withdrawing the balance, then it should show 50 to each of the users. Okay, so that means the concurrent access means multiple users are using the service at same time, and they should get a single information, not different information. Okay, so next thing is view of data. So for view of data, there were two questions in discussion forum for physical schema and for difference between three levels. So basically what happens is that uh, in each of the database system there is actually three kind of levels. So first is physical level. So physical level basically deals with physical schema, or you can say physical structure, how you are storing your data physically, or you can say in offline devices or in hard disk kind of thing. Okay, so here you have some hard disk kind of structure which is actually storing your data, and with the help of this data you can means it is the actual data you have stored. Okay, like you have heard about some in case of hard disk, there are platters, there are sectors, so and there is head, which is used to just fetch the information from uh, that disk, and that information is actually propagates to the users. So that is actually the physical structure that is stored in this physical level. Okay, physical structure, or you can say actual information or actual data. Next thing is logical level. So first was what is physical schema? Physical schema is the physical structure, how your data or data set or database, that is how it is stored physically on a device. Okay. Next is logical level. Okay. Logical level tells in which kind of data you want to store in which way. Okay. Uh, so like we get multiple data from different sites. So for a single data set, we want to store just consider as university database only. In university database, if you want to just store the roll number and name of a student, so you can store it in uh, uh, like a table or like anything else, like blocks or anything. So logical level basically deals with the way you want to logical level basically deals with the way you want to store the data from view level to the physical level, or you can say it applies the logic on raw data. Okay, so which kind of data we want to store and how we want to store, that will be told with the help of logical level. Okay, next is the view level, which basically deals with the view, or you can say which kind of information we want to provide to which kind of user. Like in university, there are different kind of users, like in university there will be faculty, there will be students, there will be staff. So faculty, student, and like you can say staff. So for different kind of entities, we will have different kind of ways. Okay, so like faculty want to retrieve information about his own, his salary, his age, or the students assigned under him. Okay, the student, for a student, the data may be regarding his faculty or his roll number or his year of joining. Is this level similar to tree tier architecture? Yeah, you can say it like. Okay, so uh, with the help of this, you can provide authorized access. You can provide dedicated information to dedicated users. Like if uh, there is some information which is not relevant to a student, and which we do not want to actually means disclose to the student. So we will authorize that information, that in the way that it should not get accessible to the student. Like there is some faculty salary. Okay, it should be every time faculty wants to retrieve this data, but we don't want this data to be disclosed to the student. Okay, so view level basically deals with this kind of cases. It means the role of this level is to provide, yeah, is to provide the relevant data to the relevant user, and to means limit the data which is not relevant to anyone or which should not be given to anyone. So it should make sure that if a data should be secured from any kind of user, it should not be given access to that user. Okay, so this is all for this abstraction. Then there were two things: instances and schema. So schema, as I earlier told, a schema is basically the structure. Okay, so about physical, let's say once about physical and logical level. So physical level is actually how you are storing data in actual way, or you can say in a device. Okay, there are servers. Okay, so in each server, like there are Google servers, they have actual data which is stored. But when we want to retrieve it, when we are providing some data to store on Google, there should be some level which should provide some kind of logic, like you are just filling a form. Okay, sign in form for it. So it wants only your Gmail and password, not any other thing. So in raw data there will be multiple things which it can retrieve. It can retrieve the timestamp, or you can say the year, date, and everything. But what data we want to retrieve, what data we want to store, and in which way, uh, like in form of table or any other thing, that is basically dealt with the help of logical level. How to find attributes in a relation when super key values are given. We will come to this later. So let me go one by one. So in logical schema, uh, it basically deals with the overall logical structure of database. Okay, so type of information a variable stores in a program, or you can say a logical kind, means the logic behind storing the data, that is basically dealt with this logical schema. Physical structure, or actual structure of database which is actually stored uh, in any device, or you can say in servers, that is basically uh, dealt with the physical schema. Why it is needed? It is needed due to physical data independence. What we provide, what it tells to modify the physical schema without changing the logical schema. Okay, can we correlate physical and logical and view level in terms of SQL? Okay, yes, we can. In physical level, just consider a local system, your device. Okay, you are using localhost to store this data. So like you write some query, uh, like this is your GUI. Okay, and with the help of SQL you are querying something. So if you are inserting, consider you are inserting some data, and what view you will see, uh, like after first thing what you do, you insert. Okay, you inserted some data into your database. That data will be stored somewhere in your system, or you can say in your memory. That is actually the physical level. Okay, then in insert there are some constraints, like you can tell about the attributes and assign values to that attribute. That is actually the logic. And when we want to view, we will provide some condition or some query, like select, like there is the employee from employee name from employee. Okay, so that will actually deal with the view level. Okay, got it? Can you please sometimes speak Hindi language? यस बोल सकते हैं. In this question, what I told earlier, in हिंदी, जब भी आप एसक्यूएल में कोई भी क्वेरी लिखते हो इंसर्ट करने के लिए, ओके, तो आप क्या करते हो, आप एसक्यूएल से उस क्वेरी को लिखते हो जिससे आप इंसर्ट करते हो डेटा को. तो वो डेटा आपका इंसर्ट होता है फिजिकल लेवल पर, और इंसर्ट होने के बाद आपके पास जो फिजिकल लेवल है वो एक्चुअली आपका सिस्टम में जो मेमोरी है वहां पर स्टोर होता है. तो वो एक्चुअली आपका फिजिकल लेवल हो जाता है. इंसर्ट जो आप कर रहे हो, इंसर्ट करने पे आपके पास एट्रीब्यूट और उसके अलावा और भी चीज़ें होती हैं, उनसे असाइंड वैल्यूज. तो वो आपका लॉजिक डिसाइड करती हैं कि आप किस एट्रीब्यूट के अंदर कौन सी वैल्यू डाल रहे हो. नेक्स्ट थिंग, जब आप उसको रिट्रीव करना चाहते हो, तो उस एट्रीब्यूट के थ्रू आप जो भी इंसर्ट कर रहे हो वो आपका लॉजिक है. देन आप उसको रिट्रीव करना चाहते हो तो आप वहाँ पर प्रॉपर एक कंडीशन लिखते हो, ओके, लाइक सेलेक्ट ऑल और सेलेक्ट एम्प्लॉय नेम फ्रॉम एम्प्लॉय. So that basically decides what view you want to get from your data. Okay. Next question is once again logic level. I think you have got it now. What is instance? Okay. So instance is basically at a particular time. That is a snapshot of your data set. Okay. Like consider this table. In this table, like for a timestamp you are just getting these three, okay, so that will be instance. If you are getting only one instance, this may be the instance, okay. So that is particular snapshot of database at a particular time, okay. So next comes is the data model. So data model is a collection of tools for describing, first thing is data, what kind of data and which data we want to store or retrieve. Then data relationships means which kind of relationships are there between two different data sets or databases. Then data semantics, like how these data are making meaning to any user and how we are feeding it. Then data constraint, like there is primary key, there are many other things, okay. We will see one by one. Then there is relational model, then entity relationship model. Yeah, physical schema and physical level. Both are actually, physical schema is the structure how we want to store the data in physical level. Okay, what are exactly means anyhow same, you can say. Sir, can some examples how find logical schema from physical schema? Okay, in SQL you have some query like if there is employee table, there are three things: name, age, and you can say salary. Okay, what you want, the data is this employee table is actually stored in physical level. Okay, with some physical schema. So if we want a logic to just retrieve it, to select all from employee, it will retrieve all the uh, data from this employee table and related values, okay. So that is one kind of logic. Next, if you want select name from employee, it will just uh, retrieve the name field from employee, okay. So logic is not a great thing, it is just a way we want to store our data, or which kind of logic we want to apply on our data. Okay, not a means high thing. So next is the relational model. In relational model, every kind of data we store it as a kind of relation, or you can say a table. Okay, in this table, these columns are basically told as attributes, or it denotes attributes, and rows basically are called as tuples, and each of the attribute is having some value. Each of the attributes are assigned some values. Okay, so in this way relational model is framed. To create this relational model or to manipulate it, there are kind of languages. So first is the database data definition language, or DDL. So in DDL, what happens, if we want to create a relation, we have to first define which kind of relation we want to create, and in that relation which attributes are taking part, and each of the attributes, what are the properties of attribute. Okay, like here, if you want to create relation of instructor. Okay, so in instructor we want to create a relation which contains this ID, then name, then department name, then salary. Okay, so for instructor we provided the attribute. Now for each attribute we should tell the property of attribute, that is data type. Okay, so we can say character, varchar, or numeric. So database definition language basically deals with this kind of thing, means we want to define our data in which way, and when we compile this, it generates a set of templates that is stored in data dictionary. So what data dictionary actually stores? It stores the data about data, or you can say metadata, or you can say database structure or schema, its primary key, or you can say authorization also, if there is. So this is the means use of DDL. Next is DML, database manipulation language. Now we have just created this database. Now we want to manipulate or to access this database in a meaningful way, or if we want to manipulate, how we will manipulate it. So for that, the language which we use is called as database manipulation language, which is actually meant for accessing or manipulating data that is organized by appropriate data model. Okay, what is data model? That basically tells about overall thing about data, how data looks like, how its relationships are, how the how its constraints are defined, or how it means what semantics are used in that data set. Now in this basically two classes of languages are used. First is the pure uh, yes. You will have PPT and recorded video after this session. So there is pure language, there is commercial language. In pure language, there is the language which we actually use to tell like in English kind of language. You can you want to tell about query, that we want to retrieve in this way, we want to project this thing, we want to select this thing. So that is actually the pure form, which basically provides the properties about computational power for optimization. Okay, second is commercial language, which has some kind of abbreviations, some kind of commands, or some kind of queries which we want to use in commercial way. That SQL is a best example for this. Okay, so this is all for DML. Next part is that is covered is key. So key is basically a attribute or set of attributes. So there are multiple things, multiple kind of keys that are covered in the lectures. We will I will go through the discussion forum problems related to this. So in discussion forum, there was a question for this super key versus candidate key versus primary. So first thing is, what is super key? So you can see from here, super key is actually attribute or set of attributes which with the help of which we can identify a unique tuple from each relation. Okay, candidate key is a minimal super key, and one of the candidate key can be selected as primary key.
Okay,
Now,
okay.
okay, now consider this. They have already given like if there is id is a super key, then id comma name will also be a super key, because id is able to differentiate. If id is a super key, then id is able to uniquely identify each of the tuple. So if we are appending any of the attribute with this id, then that will also be able to uniquely identify the attributes. Okay, so consider this example here. Okay, this table, there are five different kind of attributes. So in this, if I tell about super key, if we take all the attributes, okay, year, month, date, major, and minor, so that will form a super key. Okay, because if we will take all the keys, it will be able to identify each of the tuple uniquely. Now if we remove any of the you can say, if you want, you can remove any of the fields from super key, and it is not affecting the super key, means subset of this super key is again a super key, then there is no problem. But if a super key which you which is atomic in nature, like there is attribute or set of attribute with the help of which we can if we means detach any of the attribute from there, if we are not able to uniquely identify with the resulting key, then that will be a candidate key. Like if from here you can see one thing, that date and measure. Okay, these two things are common. If we consider date and measure as a super key candidate, then it will not be a super key, it will not be a candidate key, because these two tuples are will provide a same kind of you can say same information. But if we will just join month with date, now it will become Karthik. There is limit of 100 people at a time, so that's why your friend will not be able to join if 100 count will be over. Okay, so from just different things. Okay, difference between super key and candidate key is that subset of super key can be a candidate key. Means a subset of super key, if it is a candidate key, then it will be able to uniquely identify each of the tuple. But candidate key is actually atomic in nature. Means you can say that if any key is candidate key, then there is the huge possibility that we cannot furtherly differentiate it. Or we can say, just consider this example. We have month and date. Okay, so if we are considering month and date, then what will happen? 0113 0423 1105 and this 4 5. Okay, both attributes collectively can form a candidate key. Okay, but if we just uh, just detach any of the attribute from it, if we consider only month or only date, then this 4 and this 4 will be duplicated, this 5 and this 5 will provide means there are duplicate entries. Okay, but if we will collectively take this, it will be a candidate key. Okay, now this candidate key is enough for us to uniquely identify each of the tuple from this relation. Okay, if we add any of the key, any of the attribute with it, that will form a super key. Okay, if we add measure with it, then month date measure will be a super key, month date minor measure minor will be a super key, and if we add year, that will also be a super key. Okay, so super key is the superset of you can say candidate key. Okay, what is the primary key for this relation? There are multiple super keys. You can take any of the key. Okay, so if there are different candidate keys, like there is month date is one candidate key. If we consider year and month, that is also a candidate key. Then if we consider year and date, that will also be a candidate key. So we can take any of them and provide them as a primary key. Okay, so primary key is the minimal kind of candidate key what we actually take from the set of candidate keys. Okay, then there is the question about data normalization, why it is used. So if we will not use data normalization, so what happens is that storing multiple copies of same data happens. Okay, so if there is a table, there are different tables and they have different data of same kind. If we are not normalizing the data, uh, in many cases it happens that we actually store the same kind of data in different tables. Year and date are not uniquely identified tuples. How find number of attributes super key candidate key are given. Year and date are not uniquely identified tuples. Now year and date, if we are considering year and date, what it will provide: 2008 13, 2008 23, 2009 5, 2010 5. It is able to identify, it is able to differentiate between all the tuples for this time being. For this instance, you can say, but in general, it doesn't happen. Okay. Next is what is natural join. So, natural join, whenever we perform Cartesian product, so we want some meaningful relation out of this. So for that, we actually perform natural join. What natural join does, it basically take similar kind of values from two different relations, and based on that, it provides a final relation. Okay, like here in that PPT, there were two relations. Okay, there is R, there is S. Question assignment are discussed in course video. Yes. Okay. we take date alone is repeated as 5 and 05. So can we take date as no? If it is repeating, we cannot consider it as primary key individually. We will have to take any of other data set. Sir, did not hear. What? What? Please ask the question again. Can we solve assignment by course video? We will not solve the current run assignment. Current run assignment you have to do by your own. We will discuss some different questions based on the course material and the questions asked in current assignment. Okay. So in natural join, what happens? We in different relations, we first just take the common attributes, and based on those common attributes, we uh, actually result a meaningful relation between these two or we can say meaningful join between these two relations. Okay, so like here we can say we have B and D. These both are in both of the relations. Okay, so we just provide this condition where r dot b is equal to s dot b and r dot d is equal to s dot b. Then only we have to store that r process. Okay, and in final table we are projecting a c e with the common attribute b and d. Which key should be primary key of the database table? You can select any of the candidate key as primary key here. It is not a means very rigid kind of question. You can take year month date or month date or year date. Next is so go through this condition r dot b is equal to s dot b and r dot d is equal to s dot d. So what we will get? So b is 1 2 4 1 2. So if there is so we have three different values of b in r and three different values of b in s. uh, Natural joins. Okay, natural joins are basically to provide a meaningful relation between two different relations. Okay, so if we provide Cartesian product, there will be different corresponding relation between two different relations, but there will be some means relations which will be meaningless. Okay, so I don't have proper example for this today. I will try to provide it in next lecture. So consider if there are there is consider this table only. If we will take these uh, like there are common attributes B and D. If we consider all the attributes, then what we will get? We will get all the attributes mapped with each of the attribute of this. Okay, for alpha 1 alpha a we will have 5 mappings and likewise. Okay, and that may be meaningful, that may not be meaningful. So for meaningful kind of relation between these two entities, we just provide a filter over that, and we tell if there are same attributes, we just match with them and we will provide a different table. So here like one is there. Okay, then there is two. So if we have b, for b we have two values 1 and 2, and for d r dot b. Okay, r dot b and S dot. If we will multiply with it, or Cartesian, we provide Cartesian product, we perform Cartesian product, then what we will get if we have just, okay, let's start from very beginning. Okay, so first there is alpha 1. On first point of this, r dot b is equal to s dot b in all the cases. Okay, so there is 1 2 where it is 1 and b is 1. Okay, so there are 2 cases where b is 1. Now perform this second, oh sorry, b is equal to 2 also there. B is equal to 2 is here and here. Okay, we have 4 entries here and 3 entries here based upon first condition. Now go through the second condition. R dot d is equal to s dot d. Okay, uh, if r dot d is a, r dot d is a. If b is equal to 2, r dot d is a here, but here is just b, so it will be discarded. Now we are left with only 3 tuples, that is alpha 1, alpha a, then alpha 1, gamma a. Here we have 1 a alpha, 1 a gamma, and so here what we are getting r dot b is equal to s dot b and r dot d is equal to s dot d. Okay, so we will perform Cartesian product of these, and for next tuple there is delta 2 beta b, and there is 2 b delta. So b and 2, this is for only one condition, so that will be that we perform Cartesian product with only one tuple. So what will we will get, we will first, last they have provided a projection a r dot b c r dot d e, so that will be r dot b c r dot d and e. So first alpha 1 alpha a will be multiplied with 1 a alpha, so what we will get from here, we will get alpha. Okay, next it will be multiplied with this, we will get gamma with the same input. Then same for alpha 1 gamma a, there will be alpha and gamma, and for 2 and b there is only one tuple, so that will be multiplied delta 2 beta b and delta, so that will provide this table. Okay, so in this way what we do, it is a very big table. If we will perform Cartesian product, we will get 25 rows table. So in natural join, in brief, we can say that based upon similar attributes, we just filter out the values and we provide the Cartesian product as output. Okay. Next is there were questions about super keys, number of attributes. Yes, I'm telling it. Okay. So consider this question. Number in first question. Okay, it is number 1, number 2. It is having relation instructor, and there is attribute id, which is actually candidate key, then name, them, then mail. Okay. Then it is telling how many super keys are possible. What was the last topic? Last topic was the keys. Okay. Then we went through join. Now we are actually I am going through discussion forum questions. Okay. Set recorded videos of. So is it possible to send the recorded videos of these problem solving lectures in Nepal? That is there. That is there. There is a separate column of this dedicated to this problem solving session. The videos will be visible, I think, by tonight or tomorrow. Okay. So there is ID, which is candidate key. Okay. So now we want the super keys. We know that ID is a candidate key. Okay. Each superset of this candidate key will be considered as a super key. Each superset. So first is ID is a super key. Okay. Then ID and name will be a super key. Then ID and mail will be a super key. Then ID, name, mail. So there will be total 4 super keys. Okay. I think now it will be clear. It will be clear. Okay. So in general, if there are n attributes, then there will be 2 to the power n minus 1 super keys. If there is only one attribute is considered as candidate key. Okay. One is the attribute for candidate key. In second question, it is telling we have attribute relation R having attributes a1 to ak, and candidate keys are a1 a2 and a1 a3. Then possible number of super keys. Okay. Now we can see uh, if a1 a2 up to ak are there. Okay. If we consider these two as a candidate key, okay, then how many attributes will be there? Those are actually left, that will be k minus 2. Okay. So here it was 2 to the power n minus 1, here it will be 2 to the power k minus 2 for first case only, a1 a2. If we consider a1 a2 as candidate key, then there will be 2 to the power k minus 2 super keys. Then if we consider a1 a3 as a super key, then there will be 2 to the power k minus 2 again, because these two will be considered as 1. Okay. If the size of candidate key is 1, then the total number of super keys will be 2 to the power n minus 1. If it is 2, then these two will be considered as 1. So overall number of attributes left will be k minus 2, and we will get 2 to the power k minus 2 at different super keys. Now if we will consider this kind of relation, then it will happen that if it is a1 a2, it is a1 a3, then there will be some attributes that will be common. Okay. If we will consider a1 a2 a3, that will consist both a1 a2 and a1 a3 also. Okay. So we have to take it once only. That's why we will subtract it with 2 to the power the number of super keys this combination will create. So if these three will be considered as 1, then we will left with a1, a2, a3. Total 3 will be left from here. We will having k minus 3 attributes left, so that will be k minus 3. That will be total number of super keys. Okay, any doubt? So in this way we actually calculate the super key. Now there are some previous year questions. We will see. Repeat question 2. Okay, just consider. Okay, uh, if there is one super key, how many attributes are remain? There will be k minus 1 attributes. Okay, like I told here, if there is one sized candidate key, means candidate key is having only one attribute, then total number of super keys will be 2 to the power n minus 1. So if these two will be considered as super key, then total number of attributes left will be total k minus 2. Okay, so for a1 a2, if we consider a1 a2 as super key, it will provide 2 to the power k minus 2 super keys. And then if we consider same for a1 a3, it will again provide 2 to the power k minus 2. But there will be, if we consider a1 a2 a3 as super key, then what will happen, it will be there in a1 a2 a3 a1 a2 also and a1 a3 also. So we have to subtract it once in order to just take its effect once only. So that's why we subtract it with 2 to the power k minus 3. Main differences between primary and unique key. 1 minute. Super key given, how to find attributes of relation R. Super key may have all the attributes of relation R. What are keys? Keys are actually the attributes. Okay, if we are taking only those keys which are uniquely able to identify the relation, means the tuples, that we say it as candidate key. Okay, in super key it is possible that there may be all attributes present for the table, or there will be a subset of all attributes present in the table. Okay, so there is no proper way of providing all the attributes derived from super key. Now coming to this question, it is asking for correct representation of ML database schema. So it is ML database, so ML database will be there, all four have. Now we have to provide the uh, primary key and the attributes. So all attributes are written over there. We have to just identify which of the attribute or which set of attribute can actually work for us as a minimal candidate key or primary. Okay, so first is telling model. What is unique key? It is there now. Unique is if you are asking for primary key here, because what I am telling is that we use keys to uh, uniquely identify the tuples. So if we have primary key, that is the minimal key which we can use to identify the tuple uniquely. So coming to this question, unique means like there are tuples. Okay, with the help of key we want to identify each of the tuple uniquely. So uh, we have to figure out the proper primary key. So So first is telling model and dataset. If we consider model and dataset together, what it will provide? M1 DA, M2 DB, M2 DC, M2 DA, M3 DC. I think all of them are able to provide unique information. M1 DA is different. All of these are actually unique. So we can tell it as right. If we consider next one, there is dataset. Okay, if you consider dataset and training data, so there will be a repetition. Okay, DA and 11280 will be repeated, so it will not be the answer. If we consider accuracy, then there is a null value, so each time we have to just neglect the null value. That's why these two answers will not be there as the correct answer. So A is the correct answer here. Next is the secondary key. We have to figure out the secondary key here. So if we see SI is the candidate key, so that's why it should not be there in secondary key. First one will be discarded. If we consider we have to just provide an alternate key which can work in place of SI. Okay, so if we consider coordinate 1 and coordinate 2, so these two values will be repeated. Okay, that will not be able to work as alternative. Coordinate 2 and depth image and coordinate 2, it will provide 256, 256, 194, 126, then 1266. I think it is uniquely identifying each of the tuple, so it will be the answer. If we go with the coordinate 1 and depth image, then these two will provide repetitive entries, so that's why it will not be the answer. C will be the right answer. Next is we have to identify correct options which produces the output following output from the relation. We have to provide room key Hyderabad, Hyderabad 20,000, Sandeep Mumbai, Mumbai 20,000. So one thing is sure, that branch is equal to address, that is given here, and salary is greater than 10,000, that is greater than here. Now we have to go for each of the option and let's see which is correct. Okay. So first is telling uh, branch address. Select branch. So first and second will not be there because it is the projection sign, so it will not be there. We have to select because there are all attributes, and projection is used for selecting these attributes only or columns. Okay, we have to select the tuples or these rows. So branch is equal to address, and salary is greater than 10,000. So we have to just filter it out. Branch is equal to, if branch is equal to address, then we will have 1, 2, 3 entries are there. Kolkata, Kolkata, Hyderabad, Hyderabad, and Mumbai, Mumbai. Now we have two options. First is and salary greater than 10,000 or salary greater than 10,000. Okay, so if we provide and salary 10,000, then what we will get? Uh, Salary is greater than 10,000 is not there, so it will be discarded. Is there and is there. So that's why Rumki and Sandeep are there. So this C will be correct answer, not. Okay. Next is we have to identify the correct operations which will produce the following output. In this we have to first see R1 minus R2. So R1 has Telangana, Uttar Pradesh, West Bengal, Kerala, Maharashtra. If we will subtract R2 from it, what we will get? Gujarat is not there, Bihar is not there, Kerala will be subtracted, Maharashtra will be subtracted, we will be remained with Telangana, UP and West Bengal. That is not in the answer. R2 minus R1 will provide Gujarat and Bihar. That will not be an answer. R1 union R2. Okay, R1 union R2, what it will provide? State name, total cases. So R1 union R2, Telangana, Uttar Pradesh, West Bengal, Kerala, Maharashtra, and you can see these two are same. The numbers are same, total cases are same. So if we just consider the simple union of this state name only, we can get to the answer. Uh, then there is Gujarat, there is Bihar. Okay. Then if we will this state name, if we will consider R1 intersection R2, what it will provide? It will provide Kerala and Maharashtra. Now we have Kerala, Maharashtra one side and these much at one side. We have to provide intersection. So intersection will we will get A and M. So that's why it will be the right answer. C is the right answer. Yes, you are right. Next is the last question. Uh, which are following with a candidate key for the following instance? If we go with employee name only, okay. If you go with employee name, what it will provide? Raja, Priyanka, but Raja is repeated, so it will not be the primary key or candidate. Next comes the branch. Branch has Kolkata, Mumbai, Bangalore, but Hyderabad is repeated, so it will not be individually a candidate key. Next is employee address, employee name and address. Let's see. Raja, then Kolkata, Priyanka, Hyderabad, Raja, Kolkata is again repeated, so it will not be the candidate key. And last, employee name and branch. So Raja Kolkata, Priyanka Mumbai, then Raja with Bangalore. It is different one. Rumki Hyderabad, Sumit Hyderabad, Sandeep Mumbai. I think it is providing, it is able to identify uniquely. So T will be the right answer. So that's all from my side. Uh, let's see the A was not correct because it is having candidate key in it. We want alternative. Unique key it can't be changed. Example ID. Everyone has unique ID. So what I was telling was we want means you are going like unique key. I am telling that primary key. Okay. So thanks everyone. If there is any question, just ask. Otherwise, thank you. We will meet next Tuesday with the week 2 content. I think I hope I have uh, I tried to do my best. Okay, so ending this meeting. Thank you all. We will meet again. If there is any thing wrong I have told in this lecture, you can just go to YouTube where it will be uploaded. Just comment there. I will just clarify or correct myself because I am a human being. There may be some wrong statement I may provide in live session. Okay, I will correct if there is any. Okay, so thank you all. We are leaving there. Okay, thank you. Thank you.